Sorry. Hi. So let me just quickly share my screen. So, Professor, we are Team Sigmoid, Manoj, Ganesh, myself, Shalini, and Yamini. I don't want to actually spend a lot of time on the business problem, I think because a lot of people have already talked about it. However, I do want to underline one specific thing, and which is probably a distinction between what we've done, what we've seen so far. We started from the data set from Kaggle, the fake news data set. And we actually did a lot of enrichment work on top of that in terms of getting crawling and getting real data sets. And then actually, after enriching that data set, we have then taken up different kinds of features, for instance, political affiliation, toxicity, spam, stance detection, clickbait, news category. And between the four of us, we've divided that, and so we'll be presenting our specific features. But what's different in our approach is that we use this as the base data set. Some of our features, so for instance, I can talk about stance detection. I've actually used a model which is taken up from the fake news challenge that was sponsored by New York Times. And based on that learning, I've input this data set, the Kaggle data set that we're talking about, and then use that model to make predictions on this one, and then enhance that. And we've used that as an approach across. So for instance, Shalini's clickbait has done the same thing, where and then Manoj and everyone, we've sort of adding more and more value and data into the real one.
Very good.
With that introduction, I would actually let Manoj start.
So thanks, Ganesh, for giving quick overview. So actually, we took the modular approach. So each factor we divided among team, and individually people are working on that on different data set and making accurate and more accuracy level should be higher, 90 plus. And then we are predicting result set on our master data set. So like this, we enrich it. And then finally, we are creating master seed, master notebook, on which we will run the model to predict the fake or not fake. So that's what the approach which Ganesh told. We will go.
Very nice. So I need you guys to actually eventually write that out up top.
Yes, we did that.
Even if it's a kind of a paragraph, right? Oh, you have done that? Okay, good.
Yeah. So we did this, and all the factors we mentioned it, and who is taking care of what factor.
No. What you guys mentioned just now as your approach of training on one data set, applying to another data set, cross-fertilization, data enrichment. This is very important. So make sure you highlight it.
Yeah, that's what the unique way of doing, because this is a big problem. One person can't deal with it. So that's what we divided.
Yes, exactly. So that's a big deal. I want you guys to make a big deal out of it by stating it.
Yeah, and Professor, as we show our different modules, I'll also demonstrate how the predictions which are made are kind of very interesting, even though they were trained on a different set. We are sort of making predictions on a different data set. There's some very interesting learnings from there.
Excellent.
Yeah, so let me show you how master data looks like. So this was the Kaggle data set to start with. Then we added the real data set from WebHorse. That's a crawling thing. And then we run our models, which added these vectors into it. So this is spam score. This is probability. So how probable that is for spam. And then we categorize it, whether it's business news, sport news, or political. Because so our hypothesis was, if political news means more prone to fakeness, right? Sport news, nobody's gonna fake. So that way it might affect, right?
Yeah.
So we got to that. And then clickbait we added, so that score is there. So we will run the correlation diagram, then we will see how these factors are affecting there. So it will be quite interesting. And then we added the toxicity factor, whether that news is toxic or not. Then we will see. If toxic, then more prone to fakeness, right? So that's what the hypothesis is here. And then this is polarity, whether it's politically affiliated. So it's very good chance if it is politically affiliated, then it can be fake. So let's go over one by one factor and how we run NLP on it and how we determine it, how we visualize it. So first I will go to my sheet where I'm determining the toxicity. So I started with Jigsaw Kaggle dataset. This is initially a Google dataset. So it is dividing news in these categories. Basically, these are the messages. So these are the I think Wikipedia messages. So they are dividing in toxicity, severe toxicity, threaten, insult. All these categories are there. But in our term, we want toxicity, how severe that toxicity is, or the clear content is. So in that aspect, we want to look in some kind of binary. So what I did, I loaded this data set, and then we did the head. So we got the different category. So I run the query and determine whether this is toxic or clear. So I divided in that way. So I added one more column is toxic, and which is giving the binary output of that. This is our level to go. So here, another thing what I did, I written my own cleaning function. I referenced from there and then modified it. So it is doing lemmatization and stop word and all that. So here I customized it a little bit after seeing the content, which was not possible by applying the automated way of doing that. So that part cleansing I did. And then I applied it. This method I got. Yeah, please go ahead. Professor, you were saying
No, I was saying that sounds good.
Yeah, because it gives more power to it. So sometimes I was seeing high, then high doesn't make sense, right? In model. So we can add it. So that's how we were getting more power to it. So then I did the feature engineering to see how that can affect my model. So all kind of, I added feature columns like comment text and how many words are there, how many unique words are there, how many letter, punctuation, and all this. I will not go one by one. So this just query is there. I just applied it. And these columns are added here in our data set. So randomly I'm displaying those. Then I visualize it, how many clear messages are there and how many toxic and different category of toxicities are there.
Okay.
So I written my method to classify. So if the number is growing, means more toxic. It is lying under two categories, right? So in that way. So I just representing by numbers to category. So I converted that. So this is showing the overlapping. It means 4 type of category of toxicity is coming in picture. Then what I did the word cloud to see what words are more prominent and more frequent are there. So I'm doing this in 2 aspects, in clean messes as well as the toxic messes. So in clean messes, we can easily see what words are more, these are Wikipedia messages. So Wikipedia is there and edit is most often used. People are editing something that way and art because it's for article. So these are good words. So nothing like which can catch eye. So it's good. This is for clear messages. Then I visualize for toxic messages. So these are the words for toxic. So these are really toxic. So it's clearly defining the toxicity. So then I made a hypothesis for visualizing different aspect of it. So like if longer comment is it gonna be more toxic? Let's explore that. So this will be interesting. So I draw the chart. So this is a clean, whether message is clean or not. So this is clean and this is not clean. So you can see number of sentences. So you can compare both. See, both are same, right? Here the thin and this is. So it means it is not distinguishable whether more sentences are more prone to cleanness or toxicity. So it looks like same. So same way, number of words also. So if words are more at the bottom, so both even toxic messages are also having more. So our hypothesis, it doesn't work here. So longer sentence and more word doesn't signify the toxicity. Then other hypothesis is spammer means more occurrence of words means more toxicity. Is that the way? So let's see how it goes. So I just query this thing. So here I took a one sentence. Let's go from top to bottom. So this sentence you can see in the clean text. Let me scroll it. So you see the occurrence, this much occurrence is there. And then toxic spam. Let's see how many toxic occurrences there. So this is a lot. So more than the cleaner ones. So it looks like if message is spam means more toxic. So this is a valid case. Then what I did, I just visualizes all the columns. And then I saw the correlation because I added all the featured engineered columns, right, to see how they are affecting our model. So you can see these featured engineered column, these are having negative, so not making much sense. So probably we will not include in our model. So let's go to parts of speech. As you showed, part of speech can also affect the content, yes. Right?
Right.
So let's see that is one hypothesis. So what I did, I run the NLTK parts of speech and then loaded all these libraries. And then on the cleaner one, I run it. So we see some of the nouns are there, verbs are there. And then same thing on toxic I did. So this is having preposition is there. And preposition is not here in cleaner. And here also you can see the preposition and a lot of nouns are there. So it means if something is toxic means you are personally attacking that, right? More nouns, more preposition. So and that's
probably what, more adjectives also.
Yeah, that I didn't catch, probably. Yeah. So that is that way. If you are abusing somebody, you name it. So that's what it reflects. So it's good catch here. So if preposition, this kind of noun and pronoun is there, then more toxic. Then going to LDA. So LDA was new for me, so I explored a lot, and then I run different kind of LDAs. So I run GenSim LDA as well as the scikit-learn LDA, so to see how it works. So here I created this is a basic lemmatization, and so here I took the if. So previous one I didn't use because I was taking all the tokens. Here I am just taking more frequent ones. So I created another method here. So this, I think I followed the same article, that GitHub one which Sundar was referring. So I ran it, I took the content and then I created dictionary out of it and then vectorize it. So this is our doc2 bow, word of back. So this is the same, and then I run the TF-IDF. So I want to run LDA on both doc2wo and TF-IDF. So that's what I did. So back of word. So the same kind of topics came here. So what I observed here, the toxic content was coming under one topic. So that makes sense. Other topics looks like cleaner ones. And then same thing I did with TF-IDF LDA. So here also toxic content was coming under one topic, and then other ones were there. Then another LDA I run with the count vectorizer. And this was a scikit-learn thing. This was not just GenSim one. And then I did the same vectorization and fed it, and then run the LDA on it. So I want to see how topics are and how they are correlated. So that's what I want to visualize it. I searched several places, then I got one article and I run that. So here I'm taking more frequent one. And then I did, so since these vectors are having a lot of dimensions to it. So visualizing is really hard. So I use the TSNE. So we can use PSA also. So here I
So
reduce.
this is a general suggestion. I noticed that I think Harini used TSNE as well. It's pronounced TSNE. I mean, some people call it TSNE or TSNE. This is the one of the people who invented Spacey, which is a competitor to GenSim, created the TSNE algorithm. It's probabilistic, tensor board user, etc. Great for visualization.
Yeah.
Right. So actually it helps how topics are there. So that's what is very interesting. I want to show that. So then I use the bokeh plotting thing, and I written all this code. So actually there was an article which you also shared. That article was not working because that was written on older versions. So a couple of modifications were required on it. So I did those, and then finally I was able to run it. So that's how all the topics are looking like, and it is relating those topics to the actual content. So here I was looking how this actually makes.
Yeah. Okay. So in terms of this equation that we've been talking about, I took in specifically stance detection and spam detection. I'll also very briefly touch upon another very interesting thing that Professor you sort of mentioned as a brief note in terms of predicting what a particular person might say or a politician might say. But before that, I'll just quickly jump over to stance detection. Why I chose stance detection is very specifically in Fake News Challenge, which was sponsored by New York Times. They say, what is really fake news? And like Professor, you talked about that it's a very difficult process, sort of problem to solve as to what is truth or what is not truth. So it is very important to reduce the definition, to give it a very solid definition of what fake news is. According to stance detection, the thing that we're trying to say is, and according to New York Times actually, that a made-up story with an intention to deceive. Now, how do we identify if there is an intention to deceive? One way to look at it is if the headline and the body of the article, they are not in sync. And that's really what this stance detection is about. That I see that the line says something and the body says something. And the whole process around stance detection is whether they agree, whether they disagree, whether they are unrelated, and we've classified like that. There's some very cool things in terms of how scoring is done for this, which is completely different from how we've been doing scoring for all other methodologies. So I'll just go through that. As a first step, like this is the feature selection process, and I've kind of modularized the course a little bit, where we're basically doing things like, sorry about this. We are doing normalizing words. Then I did tokenization, cleaning the words, where we are either converting them to lowercasing, trimming them, removing non-alphanumeric characters, removing stop words, and then we are loading the features. In terms of the features, there are 4 broad features that I have used in this. One is word overlap features. Now, word overlap features are essentially looking at a headline and the body, and then trying to do a comparison between like how many words were common. So there's an intersection on the words in headline and body, and then doing a union between the words of both these corpus of words really. For refuting features, I'm looking at this sort of small library of words, which are more which indicate that there is a claim which is essentially refuting something. Like, for instance, a climate change hoax, or deny climate change, or things like that. So that's kind of another feature to it. Third feature is polarity features, which are essentially talking about, like, how polar is this argument becoming? So whether you're denying it, so words like hoax, fake, fraud, and things like that are taken into it. And in each one of these, in each one of these features, we're doing a similar process, right? Where you basically take the text, you tokenize it, and then you look for the words that are in that specific feature library set, and then you rank it. And then that the rank for each word from each feature, it kind of becomes a whole array of features towards the end. And give a more concrete example towards the end about that. And then there is this approach of actually comparing n-grams between the headline and the body. So essentially, if there are certain group of words which are common between headlines and bodies, then that is the fourth feature that I'm looking at. So having talked about that, this is reading the data set, which is actually provided by the Fake News Challenge. And like I'd earlier mentioned in the beginning, that this model training will do on the fake news, on one data set, which in this case is Fake News Challenge data set. And the actual prediction will do on our original data set, like Manoj was showing the Kaggle data set, and as we are enriching that. So this is like the standard reading of CSVs and looking at bodies and stances. Just to give a quick sense of what this looks like. So this is, So this is the file which basically has article body, and there's a number associated with each one of this, and then this is a headline, and then there's a corresponding body ID, and then there's a stance. So we're training it on labeled data set initially, and then we'll switch to the predicting on our data set. This is again a standard train test model split. One thing that is kind of interesting that I explored here was K-fold classification, which was basically saying that you actually take your data set and you divide it into a certain number of folds. And based on, and then you train your model on different folds, and then use that to basically make a prediction, or and use that to optimize the model performance. And this is something that was actually, that has probably, it takes, each time I run this on this data set, it takes about 45 minutes for that whole thing. So I'll not.
Makes sense. So Ganesh, let me ask this. So how many other team members do you have to present?
We have two more.
Two more. Okay. So I'm going to have to ask you guys to do the following. Either condense the next to 5 minutes each if you can.
Okay.
And if you want to have a separate session, I'm happy to have a separate session for you to go through this in detail.
So actually, I don't need to, I honestly don't want to go through this code review sort of a process. And I stated what I'm doing. I'll go real quick. So
yeah, that's cool. We can do that later because I would like to walk through stuff with you guys eventually, but that's good. Okay.
Cool. Okay. I think one highlight that I do want to show here is the way scoring is done here. So I'll just show this. So for instance, on the row name side, you have seen that these are the actual models. So when you're actually, sort of running it, and the top row is the predicted one. So if my model predicts that the headline and the body kind of agree with each other, then we sort of classify it there. If they disagree both, then we classify it there. And then the scoring that is done, sort of the overall model is, there's a scheme around it. And this is something that I have picked up from a GitHub repo. A gentleman has done it. And I thought this was very ingenious. And this is also very different from the kind of classification or the confusion matrix that we have been working with. Okay. Having done that, then this is the generate features part, where essentially we put in the stances, we given the overall data set, and then we basically create these different feature sets. So these are the different features that I showed, the different methods that I was showing: word overlap features, refuting features, polarity features, and then hand features. After doing this, this is where the actual this gradient boosting classifier sort of comes into picture. And this part, this kind of, it takes like about 45 minutes to run, because it basically creates one fold and then trains it on multiple others, and then gets the values and optimizes the results that we're getting from it. In this scenario, you would see that we get a score of about 79% accuracy of predicting the agree, disagree, discuss, or unrelated pieces. Was there a question?
No, go ahead.
Okay. Then there was a thing about generating features. So now here, essentially, now what I'm doing is I've taken that. I'm now generating the same features for my Kaggle data set. So I create a fresh model here, like, fresh method really. And then I read my fake news data set. I do some, pre-processing of text over there to kind of remove essentially nans or empty strings or non ASCII codes. And then, okay, this is, so just taking a look at the shape here. This is generation of features in XFN. And XFN, essentially, I'm just showing this for the first 100 records. So if you remember those 4 different methods, they translate into 44 columns, depending on what word is present and what is not present. And then this is how the kind of array looks like. Using this, we basically use the best fold, the one that we got from that classifier, and we use that model to actually predict values of the stance. So for these 100 records that I'm talking about here, these are the predicted values. So like in this scenario, essentially the prediction is that the headline and the body, they are kind of discussing. There is no element of I'm agreeing to the headline. So I'm not supporting it, or I'm not disagreeing with it, but I'm more discussing it. So it's probably more neutral. And that's kind of what discuss means. Unrelated it when somebody could say that, oh my God, and or UFO landed, and then you actually write an article about Trump or something like that. So that's kind of how this is to be read. And then I'm just doing some processing to actually take these predicted values and just populate this into the original data set that we started from. So if you see, this is the stance, discuss, and this is the title, and this is the text. So for instance, the title is Muslims busted, they stole millions, blah, 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 blah. And then there's text about something. So then the prediction is that the body discusses what the headline is about. And then I take an output. So this is for stance detection. Actually, I would skip doing spam detection, because spam detection we've already covered, and it's like one of the factors and not necessarily the most relevant one. And done standard processing, looking at text, did the training using SMS spam collection data, and then use that to actually predict. This is some analysis that you've done on SMSs in terms of what kind of features do we have in a certain SMS, which is more spam. So like in this, you see that spam messages tend to be a little bit longer than normal messages. So I would probably not spend much time and give my teammates time. One last thing that I do want to show is, so this is a model that I did on the liars data set. And here is it actually predicts. So this is like dynamic, like I can write something. So for instance, if I say Trump was funded by lobbyists. And so let's see what this model, so it says this is true, and it gives a truth probability score. So like Professor, you were saying, there, that there is a probability associated with it.
Right.
And so that's kind of what it is doing. And just to make sure that I've not hard coded this, and
right.
Let's try another one, like Hillary Clinton was funded by lobbyists. Now this is saying false. I probably would not 100% agree with this. I would think probably both were funded by lobbyists. But I guess based on the data set, based on the liar data set, this is what it is saying. I don't want to go through the whole code code walkthrough with this, but I think this is a sort of a very generic veracity sort of prediction. And although this particular piece I have not integrated into our model, but at some point of time we would do that.
Okay.
And with that, I will quickly hand it over to Yamini.
Good job. Very good.
Thank you.
Hi, Professor. Hi, hello, everyone.
Hello.
So I am going to present on the political affiliation. So before presenting my topic, so I found two interesting websites that would help in analyzing the media bias. So one was All Sides, which would give the rating of left, right, and center. And other one, as I told in last week's class, it is Media Bias Fact Check. So you can see the tabs which should convey which belong to left, least, right, and center. So quickly running through my uh, workbook notebook. So I have just used as a new data set, fake or real news. So this data set contains the label as well as the it contains the fake or real label. So I used this as a corpus for training the model. And what I did was I essentially I've done vector classification using count vectorizer, TF-IDF, and then after that I just find the confusion matrix for both of the approaches, and I found the passive aggressive classifier approach should be more accurate. And after that I found the words which would be like categorized more as fake and real. So I found the features here. Then after that, after training the model, I used this Kaggle fake news data set. So this data set, this is the original data set which we are using from the Kaggle website. So this contains all the fields. And so here I just plot these values to find the bias, which type of news, and we find more of bias kind of news here. And so yeah, and coming to the political affiliation, what I have done is like based on the sources, I have categorized certain URLs that belong to left, right, and center. So here I have created an extra column called source URL polarity. So I have considered to be like if the Democrats belong to the left, so I would categorize somewhere them between 0.0 to 0.49, and the center I classify them as neutral, so it's 0.5, and the Republicans I classify from 0.5 to 1. So I assign those value to them. So for the news sources whom I didn't find the values, I just categorize them as unknown. So mostly the neutrals would be 0.5, the unknowns would be 0.5. So here I'm adding the values here. So you can see I have added the source URL polarity, and I have enriched the data set. And then regarding the news top 10 words that help in associating the political affiliation, I have done this using count vectorizer. Then coming to the confusion matrix, I have done like classification of this things which I have done in using token TF-IDF vectorizer. And so I performed LDA to remove to do the pre-processing and the cleaning the fields, and I tokenize the words. Then quickly running through it. So I found which websites are credible and what are the contents that are real and fake in each of these news sources. So I have this is the credibility of the news sources. And so then I have run through the classification models, and I found that random forest classifier gave me highest accuracy. And so coming to the data set which I generated, so this is the data set. So everyone created a separate field. So I have added my column here. Like, so this one indicates it belongs to right. So you can see it keeps on changing based on the URL. So so 0.5 indicates it's neutral, and 0.9 it's slightly aligned. It's nearly aligned to left, and 1 indicates it is right. So like, yeah, so this is, we have added all of our features here, and based on this we would come up with a polynomial equation, and that will help in determining or fake or not. So I'll pass it on to Shalini to present her feature. Thank you.
Excellent work. That was fast, but you've done very good work.
Thank you, Professor. Considering the time, I just ran through the notebook very fast. So thank you.
We'll set some time so that you can walk through this in more detail with me.
Sure, yeah.
That's good.
Okay, so I'll just walk you through one of the components that is about the clickbait. Other feature is regarding echo chamber that I'm still working on. So what we've done for clickbait is we've tried to first find certain characteristics which are present on a particular, the title seems to be a clickbait. So when we read through certain articles, what is the kind of capitalization ratio is quite high when they are clickbaits, or they have more questions or exclamation marks. What is the log ratio of certain words that they have? And we've tried to find, we've done a TF-IDF, and we've tried to see what is the factor that we get from there regarding the words that are available on clickbait titles based on the dictionary we had. So the very first thing we've tried to visualize is the length of the message and or the title that we have. And we can clearly see that clickbaits and the non-clickbait titles have a differentiation over here. And then the capitalization ratio. So any kind of clickbait, you'll find that there are more capital letters available on them. And if you do another analysis, that what kind of exclamation points have, so of course, clickbaits had a little lesser of them. That's what we found in our data set. And the exclamation questions, I think this is for the question mark that we've done. After we've done these kind of, we found these particular values, we've tried to find the ratio within a sentence, and we've tried to populate all these values on our enrichment columns.
Okay.
And we've tried to figure out the top 50 words available on our clickbait titles. So we've just picked up all those articles or all those records which were termed as fake, and from them we tried to figure out the first 50 characters and first 500 words also, and then tried to find that are they occurring, and what is the one of the other things that we've done is that what is the log to these words ratio. We've calculated it manually, tried to come up with some kind of a formula over here. Another thing was that we applied it's just a visualization to see that what kind of words or sentences were with clickbaits and non-clickbaits. And we've done TF-IDF, and we've tried to, get what were the, the factor values that were there. We've populated it into our, those values over here in the record. By using all these things, if you look at a particular record, so what was the length of the headline, what was the caps ratio, question, exclamation point, what were the log ratio or the TF-IDF score based on the dictionary that we have created. We took all these factors and tried to classify. So we've used various type of, and we've tried to visualize also, see how they vary, and I'll just quickly walk you through. Once we've classified it, we could basically classify it's a clickbait or a non-clickbait. So during classification, what I had done was that we've used the logistic regression, and we've used the probability score that is used by logistic regression, and we've tried to use it as our clickbait score. And to our algorithm, we had fed all the characteristics we had taken up. Logistic regression had done pretty well in this case. I've tried on all other, XGB classifier, we've done a random forest and quite a lot of things, but finally found that logistic regression was doing a better job over here.